All right, so next in this unit, we're going to learn about what is called an arithmetic sequence. And we're also going to learn about arithmetic series. So an arithmetic sequence is a specific type of sequence where the pattern is that it consistently adds or subtracts the same number. So consistently add or subtract the same number. So if the pattern is that it goes up by 3 and then by 5 and then by 7, while the pattern is addition, it is not considered to be an arithmetic sequence because it adds different numbers each time. So an arithmetic sequence would have to be a sequence where it maybe added 3, added 3, added 3, added 3. So that could be like 1, 4, 7, 10, 13. That would be an arithmetic sequence because it consistently added the same number each time. There's something called the common difference, and the notation that we use for that is just the letter D for difference, and it is the number that is added or subtracted between each term. So if the pattern is that each number goes up by 3, then the common difference, the value for D would be just 3. If it goes down by 5, then the common difference, the D value would be -5. Again, we have the two types of formulas. We have explicit formulas and we have recursive formulas. So the explicit formula for an arithmetic sequence is a sub n equals the first term plus n minus 1 times the common difference. And it makes me really uncomfortable to put this on the very end right here because I like to see these numbers as coefficients for a parenthesis. But they really do put it on the end. And when you're given the formula sheet for the NCFE, it's also going to be on the end. So I'm just going to be consistent with what they give you there. The recursive formula is, first you have to know what the first term is, or the second term, or the third term, or whatever, but typically we're going to say the first term. And then we say a sub n equals the term before it plus the common difference. So if you're adding 5 each time, then find the term before it and add 5. All right, so we're going to go ahead and go through some examples. So I'm going to say that from the given sequence, find the value for D, the next 4 terms, the explicit formula, and the recursive formula. So we're just going to find a bunch of different things for each example that we're going to do. So the first sequence we're going to look at is 17, 12, 7. And so we're going to find the common difference. The value for D is that if I look at this, I can see it's subtracting 5 each time. So I'm going to say -5. For the next 4 terms, I'm just going to subtract 5 to find the next 4. So 7 subtract 5 is 2. Subtract 5, subtract 5, subtract 5. The explicit formula is the first term plus n minus 1 times the common difference of negative 5. And yes, you can leave it exactly like that if you want. The other thing that they'll do is they'll kind of simplify it, so like get rid of all the parentheses. We're going to go ahead and do that this once just so that you know how to do that if you're like doing the NCFE and you're checking a multiple choice answer. But this answer is totally fine to leave. So for our class at least. So if you wanted to get rid of those parentheses, you would have 17 minus 5n plus 5. And then you could say this was negative 5n plus 17 plus 5 gives you 22. So these are two perfectly acceptable ways to write that formula if they were giving you a multiple choice. My guess is they would probably have simplified it and written it like that, but you don't have to. All right, the recursive formula, I could start you off on the first term or the second or the third or the 27th term if I wanted to, but I'm going to go ahead and just start on the first and say the first term is 17. And then the pattern is that each of the terms goes down by 5, so I'm going to say the term before it minus 5 is how we find each additional term. Okay, example 2, we're going to use the sequence 12, 21, 30. So the common difference is 9. These are going up by 9. The next 4 terms, so if I add 9, I get 39. If I add 9, I get 48. Add 9, 57. And then add 9 and get 66. The explicit formula would be the first term plus n minus 1 times 9. And again, you can leave it just like this. If you want to move the 9 in front of the parentheses, you could do that. If you want to distribute the 9 and get rid of the parentheses, you're welcome to do that as well. The recursive formula is going to be, I should start off at 12, and then my pattern is to add 9 each time. Okay. So here's our next example problem. So we're going to use that same formula. There's just a lot of different ways they can ask you questions about arithmetic sequences. And so what I'm going to do now is just go through some different examples of things that they could ask you and how you would go about finding those. So here's the example we're going to do for this one. We're going to say find the 68th term. And they're going to give us this sequence. And typically they'll tell you, I didn't write it because I didn't feel like writing more words, but typically they'll specify like this is an arithmetic sequence so that you know specifically with something added or subtracted each time. Or if they don't tell you it's an arithmetic sequence, then they'll probably give you more terms than just 3 so that you could really see the pattern. So if I want the 68th term, then I need a formula to work with so that I don't have to just continue this pattern for 68 terms. And so the formula that I'm going to want to work with is the explicit formula, because that's the type of formula that just allows me to plug in a number. If I use the recursive formula, then I have to find all 68 terms anyway. So I'm going to look for the explicit formula. For the explicit, I need the first term, which is 25, and I need the common difference. And if I look at this from 25 to 17, I don't see it as easily, but from 17 to 9, I say, oh, those have a difference of 8. And so I know that goes down by 8, and then going down by 8 makes sense there as well. So I'm going to say the common difference is negative 8. So that means that the formula is first term plus n minus 1 times negative 8. And so if I want the 68th term, all I have to do is plug in 68. And when I plug that in, I get negative 511. And so that's what the 68th term is. So in a pinch, if you forget how to do that, you can just, continue the pattern for a long time. And I think for the most part, from what I've seen of kids when they take the NCFE, they're usually not necessarily crunched for time. So if you need to do something like that, then you probably survive just fine. All right, here's the next example. We're going to find the first term of the arithmetic sequence if a sub 25 is 139 and d equals 3/4. Okay, so again, anytime we're looking for specific terms, we're probably looking at the explicit formula instead of the recursive formula. With the recursive formula, we just subtract 3/4 until we got back to the first term. So here I'm going to say I'm working with my explicit form. I'm just going to go ahead and write it out. Not equals, plus. Okay, so the 25th term is the first term plus 25 minus 1 times the d value, and the 25th term equals 139. So I'm going to cover this up. This is the equation that I'm solving right here. So I have the first term plus 24 times 3/4 equals 139. 24 divided by 4 is 6. So I can really think of that as 6 right there. 6 times 3 is 18. So the first term plus 18 equals 139. Then I can go ahead and subtract the 18 over, and I get that the first term is 121. Okay. For the next example, find d for the arithmetic sequence where A1 is 75 and A38 is 56.5. Okay, so for this one I'm going to think about what the d value represents, and the d value what d represents is the amount that is added or subtracted per term, right? So another way of writing this is I'm going to say the amount added or subtracted per term. So if you want to find it for one term, then you're typically just going to have a number. But if you want to see multiple terms, which is what we have here, right? It went from first term to the 38th term. We can see the amount that you went up or we can see the amount that you went up or down, and we can divide it by the number of terms it took to do that. And then we'll see the d value for just one term. So for here, to solve for the d value, I'm going to say it started at 75 and it went to 56.5. So I'm going to say 56.5 minus 75. That's going to tell me how far it went down. And then we're going to divide that by 38 terms minus 1 to see it went down this much and how many terms did it take to do that. So it went down by 18.5. It took 37 terms to do that. So if we divide those, we see that the d value is -1/2. It went down half between each term. So again, if you're given two different terms, if you can see, this is kind of like finding the slope. The common difference is a slope. It's a rate of change that's consistent. And so here, the way that we found it is we just said how far did the numbers change by? What did each term change by? And how many terms did it take you to do it? And then we'll figure out each change per one term.